Greetings, mathophiles, and welcome to the second in a series of 3 videos on binomial probability. The first one gave an introduction and ended with a formula and a listing of the formal criteria for a binomial. This video will explore the uses of binomial probability commands on the TI-84 calculator, and the third one will take a look at the shapes of binomial distributions and how those are influenced by the values of p and n. This video is going to be centered around a problem involving a free throw shooter. This is Brianna from the first video, and she's still hitting 65% of her free throws. But we're now supposing that she's in a game in which she takes 7 shots. The shots are independent, and we want to know the probability that she hits exactly 3. And this, of course, would be a binomial probability because she either hits or misses over a fixed number of trials with a constant probability, and we've assumed the trials are independent. So we could employ the formula. We could say that there are 7 choose 3 ways that she can make 3 of her 7 shots. And each of those outcomes involving 3 hits and 4 misses is going to have a probability that is 0.65 to the third times 0.35 to the fourth, because we have these 7 independent events, 3 of which have probability 0.65 the hits, and 4 of which have probability 0.35 the misses, and we could punch this out on the calculator and we'd be good to go. But there's a more direct route, a more specialized route that you can take. And what you do is you go to the dister menu for distributions is right above the vars key for variables, so that's second vars for dister. And we're going to arrow down a ways to the command Binomcdf. Stands for probability density function. You certainly don't need to know that. This is the command we're going to use to get individual binomial probabilities. So you want PDF, not CDF. And we'll see in a few moments what CDF has to do with. So this is not portable document format. This is probability density function. So I'll hit that command, and you'll go to a dialog box. And it's very easy to use. It asks what are the number of trials, you say 7. It asks what's the probability of success on a trial, you say 6.65. In our case, it asks what's the X value, that's going to be 3, because we want the probability of 3 hits. And it will then paste this command into the home screen. Now, if you have an old enough calculator, instead of seeing a dialog box, you'll just see the Binomcdf command with an open parenthesis. All you have to do is enter your n, a comma, your p, your comma, and then the number of successes that you're asking about. I hit enter, I get about 0.144. And I'm going to boldly claim that that's exactly what you would get if you use the formula as we wrote out there. What if we have a slightly more involved question? What is the probability she hits no more than 4? Which would mean she hits none, or she hits 1, or 2, or 3, or 4. Well, we could calculate each of these 5 probabilities separately, but there is an easier way. And that's where the binomial CDF, or cumulative density function, comes in. You don't need to know that term either. So what the CDF command does, and you get to it in the same menu, it's right below the command that we just looked at. We'll arrow down to binomial CDF, and we'll hit enter, and it looks the same, right? So we give the number of trials, which are 7, we give the probability of success, which is 0.65, and we give now this X value. But what this is that instead of a single number of successes, this is going to give us the total of all the probabilities for 0 successes up to and including our value. So we want to enter 4, because we want the sum of all the probabilities of all the numbers of successes 0, 1, 2, 3, 4. Paste it, hit enter, and it's about 0.468. So that's a very handy feature. It saves you having to add multiple binomial probabilities after having first calculated them. But you need to be a little bit clever in how you approach using it, depending on exactly the problem that you're presented with. In this third one, we have the probability she hits at least 3, which means the probability she hits either 4 or 5 or 6 or 7. This is not what the command is designed to do. The command is not designed to go from someplace up to n. It's designed to go from 0 up to someplace. However, we can get around this because this is the complement of the probability of hitting 2 or fewer. So all we have to do is use this command, and I'm just going to repaste it and change that 4 to a 2. All we have to do is use this command and then take the value that it spits out and subtract 1. So 1 minus answer equals about 0.944. So you have to pause and think a little bit about how you're going to use this cumulative density function command. But in fact, it's not so difficult. And once again, it saves us from doing a bunch of separate binomial calculations. If you wanted to know the entire distribution, you could actually do that. You're probably better off using some sort of calculator program or maybe Desmos. But if all you have at your disposal is the calculator itself, you can go into the list editor, so that's stat edit. You can enter in one column the numbers of successes that are possible. And that's, in this case, that's anything from 0 to 7 because there were 7 trials. There are slicker ways to enter lists of this kind, but you can certainly do it by brute force. And then we can arrow up to the top of some other convenient column, and we can pull up this Binomcdf command. So second, distributions, down to Binomcdf, and then we have the trials, we have the 0.65, and then for the x value, we're just going to say to look in L1. And then we'll paste it in, and we'll hit enter. And there is the entire probability distribution. The probability for all the numbers of successes from 0 to 7 when n is 7 and p is 0.65. Sometimes a handy thing to be able to just have them all and be able to look at them. I hope this has been helpful. Please seek out the third video, which again will have to do with the shapes of binomial distributions and how those are measured and how they're influenced by n and p. Happy mathing.